The moment you type a website address on a browser and press enter, your browser begins a journey through a network of DNS servers, routers, databases, security systems, and web servers. And all this happen within just 1 second. So what exactly happens between the point of pressing enter and the point where you see a web page open? Let me break it down for you. So let's use this example. You want to access the website here. The first thing the browser does is to separate the website into different parts. The first part is HTTPS, Secured Hypertext Transfer Protocol. This part simply tells the browser to use a very secure connection. The second part is www.example.com. This is the part that tells the browser which specific page to request. Now, HTTPS normally uses port 443. This is more like the specific door that is used for that web server traffic. I hope you understand. Now, let's start the journey. But before we start, please note that computers don't find websites using names. They find websites using IP addresses. And as an end user, you don't know the IP address, you only know the name. So what do you typically do? You go to your browser and type www.example.com. Now your computer has to do the work to find the IP address of that website. And that's when the DNS server comes in. The DNS is domain name system. It's like the internet phone book. It's a server that has all the IP addresses of all the websites in the world. So your browser simply asks this DNS server, what is the IP address for this website? The resolver performs some set of recursive queries. And how does it do it? Firstly, it checks its own database if it already knows the answer, and by the answer I mean the IP address of the website. If not, it contacts the root DNS server and then the server responsible for the .com domain, and finally the website authoritative DNS server. That server returns the correct IP address, and finally your browser knows where the website is located. Now, before sending it across the internet, your computer or your mobile phone first sends it to your local router. The router is like the gateway between your home network and the wider internet. The computer may use ARP or Address Resolution Protocol to find the router's hardware address. Next, the browser establishes a secured connection with the server using TCP, otherwise known as Transmission Control Protocol. This happens through a three-way handshake between the client, the browser, and the server. SYN, ACK, and ACK. The browser basically says, I want to connect. The server replies, I am ready. Then the server confirms, let us begin. Now, because the website uses HTTPS, the browser now performs a TLS handshake. TLS means Transport Layer Security. The server sends like a digital certificate, which is very similar to an identity card. The browser checks if the certificate is valid, whether it has expired, or whether it belongs to the correct website. And if everything is correct, both sides agree on encryption keys. This is a protection mechanism that protects the information traveling between your device and the server. After this, the browser now sends an HTTP request. It simply tells the server, I want this web page. The request may include website hostname, the type of contents the browser accepts, the browser type, and many other information. The request is usually broken into pieces called packets. These packets travel through routers, internet service providers, backbone networks until it reaches the website server. And don't leave yet, the next part is where the web page is actually built. For telecom enthusiasts, if you like technical explainers like this, make sure you are subscribed to my channel. Subscribe now. I have more in stock for you. Now let's go back to it. Large websites usually have many servers behind it. A load balancer determines which server should handle your request. That server may check your login details, read cookies, run application code, and even contact a database. For example, a social media website like Instagram may request your profile, messages, notifications, and recommended posts. The server then prepares a response containing HTML, CSS, JavaScript, images, videos, fonts, and other files. It may also send a status message such as 200 OK, which means the request was successful. This response travels all the way back to your device. Now, the browser reads the HTML message and creates the DOM or the document object model. The DOM represents the structure of the web page. Then the browser reads the CSS, which controls the colors, fonts, spacing, and layouts. The JavaScript adds interactions such as buttons, fonts, menus, and live updates. And finally, the browser calculates where everything should appear, paints the text and images, combines the layers, and sends the final output to your screen. And take note, even after the page appears, the browser may continue making background requests. It may load advertisements, notifications, videos, or fresh content. The browser may also save some files in its cache. This is why it's faster the next time you visit the website on the browser. So what do we learn? Let's make a quick summary. The DNS finds the address, the router moves the packets, the TCP creates the connection, the TLS protects it, the server processes the request, and the browser forms the web page on your screen. And this happens almost instantly. Now you understand what happens when you type a URL and press enter on your browser. Which part of this process surprised you the most? Drop your answer in the comment section. And don't forget to subscribe to my channel, naijatelcoguy, for more simple explanations of telecom and technology. Stay smart, stay connected, and I'll see you next time.